Good morning.
Namaste, sir.
Namaste. I didn't hear any voice before, so I was wondering if anything wrong with my system. No, it's not.
No, sir. Sir, actually, we are waiting for you only. You and Srinivas Rao, sir.
Yeah. I think there is some echo from the YouTube, I think.
No, sir. Actually, we are waiting for you only. You and good evening, sir. Actually, our today's first speaker had joined 15 minutes ago. With your permission, I wish to start the session, sir, without wasting anybody's time.
Sure, we can do that. It's exactly 5:32 right now,
Yes,
right? So it's on time. Please go ahead.
yes. Thank you,
No,
sir.
we're not late. We're not late. Please go ahead.
Thank you. Good evening, one and all. The auspicious today's guests of this FDP and the distinguished speakers and my dear colleagues, delegates, and my dear friends. A very warm welcome to the sixth day of our 1 week international faculty development program. Today also we are having two elegant people ready for delivering their valuable lectures in front of all of us. For this, first of all, I wish to say my heartfelt thanks to Dr. S. Renuka Devi ma'am for accepting our invitation and for giving your valuable approval for to act as a resource person of this FDP. Thank you so much, ma'am. In this occasion, it's my privilege to introduce to my all the gathering here. Today's distinguished speaker, Dr. S. Renuka Devi ma'am, did his Master of Engineering and PhD in Engineering, and she is from the Faculty of Electrical and Electronics Engineering. And currently, she is working as Assistant Professor Grade 2, SCSVME University, Enathoor, Kanchipuram, Tamil Nadu. And coming to her professional summary, ma'am is very experienced academic professional with over 18 years of teaching and research experience. And she is very good expertise in electrical and electronics engineering. And she is having a specialization in power electronics and industrial drives. And ma'am is a very good mentor to students, and she is leading some research projects also for both UG and PG students. And she is organizing many academic events in her workplace. And coming to her professional experience, currently ma'am is working as assistant professor grade 2 at Sri Chandrasekhara Saraswati Vishwa Mahavidyalaya, Kanchipuram, and she is having a very good teaching and mentoring experience for both UG and PG students. And she had acted as a session chair for many academic conferences, and she had attended and organized many workshops and faculty development programs. And currently, she is a research supervisor in power electronics and drives for PG students. And she is an editor of an issue for university newsletter. And coming to her research and publications, she had published many research papers in Scopus Index and UGC approved journals. And she had presented many papers at international and national conferences and published a book on the future of IoT, modern technology, and industry automation. And she is a specialized person in power electronics, voltage sag mitigation, and renewable energy systems. And her area of expertise is in power electronics and drives, renewable energy systems, power quality improvement, and electrical machines and control systems, electric circuits. Ma'am, we are very fortunate enough to have you as a keynote speaker and distinguished speaker for today's session. Thank you so much, ma'am. Over to you, ma'am.
Thank you for your warm welcome, ma'am.
Thank you, ma'am. Thank you.
Can I start the session now?
Yes, ma'am. Yes.
Yeah. Can you please tell me whether my screen is visible?
Sure, ma'am. Now it is not there. So please share your screen. Madhu Sharma, ma'am. Very good evening, ma'am.
Good evening, ma'am. Good evening, all of you. Good evening, Prakash Rao, sir. Good evening, Renuka Devi, ma'am.
Yeah, good evening, ma'am.
Ma'am, your screen is visible. Just make it full screen, ma'am. Presentation mode.
One second.
One request for the audience, please turn on your video, as many people as possible. So it will be lively.
Ma'am, is the screen visible now?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes,
Yes,
it
ma'am.
is.
It is visible.
Yeah, okay. So good evening to one and all. So myself, Dr. S. Renuka Devi, from a faculty from the Department of EEE SCS University, Yenathur, Kanchipuram, Tamil Nadu. So as Madam introduced me, I'm actually currently doing my research work and done my research work in the area of power electronics and drives. And currently, today's session is on the topic power electronics and biomedical systems, enabling advanced healthcare solutions. So this presentation is going to cover the introduction about biomedical devices, the DC to DC converters, and the current state of art in both the DC to DC converters and biomedical devices, and the future research scope. So as many may be aware of power electronics is the electronics which is useful for converting the energy with the minimum of energy wastage. So it actually, there are various types of power electronic converters, which like AC to DC converters, which converts AC to DC, and DC to AC converters are available, and AC to AC converters are available, and DC to DC converters, which are known as choppers. There are a variety of various power electronic converters are there. The type of converters depends upon the application what we choose. And now coming to the biomedical systems, actually they are electronic devices which are used for diagnosis, monitoring, and treatment of medical conditions. So now why we need to integrate this power electronics into biomedical systems? So that is the main question here. So let us first answer for before the advent of power electronics, how was the biomedical systems? Actually, the biomedical devices before the advent of power electronics, it were bulkier in size, and it was not controlled automatically. Like, for example, we can't control the parameters of the biomedical devices. Like, if you want to control the voltage, we have to do it manually. It can't be done automatically. So after integrating this power electronics into biomedical system, everything changed dramatically. Like the compactness, precision, reliability, and energy efficiency, everything was, it was a drastic change after integrating power electronics with biomedical system. So this image, what you all are seeing is a pacemaker. As you all know, pacemaker is a biomedical device which is used to regulate the heartbeat whenever there is a irregular heart rhythm. So this image is actually the pacemaker in early 1950s or 1960s. So it is an external pacemaker, so which is very big in size, and during that time implants were not available. So, but if you see this image, which is very, very small in size, and which is the world's smallest pacemaker, which is available now because of this power electronics. So power electronics actually has made many magic in not only in biomedical devices, in all in many our home appliances, electric trains, electric drives, renewable energy applications. So these pacemakers are nowadays very important as pacemakers and available as implants now. So with the help of power electronics, the pacemakers will be having DC to DC converters inside the pacemaker. So what is the role of DC to DC into the pacemaker, we will see in the next slides and all. So due to this power electronics, the pacemaker size has become very small, and also the lifespan of the pacemaker has increased and the efficiency has increased. So this is why the reason why the power electronics has to be integrated with the pacemakers, and not only pacemaker, all other biomedical devices. So this actually, in this tabular column, I have listed various biomedical devices. So these are actually implantable biomedical devices. So apart from this, we have various biomedical devices which are implants. But I have listed only the most commonly used implantable biomedical devices here. So the first one is the pacemaker. The purpose, as you all know, it is to regulate heart rhythm. And it uses a battery which has to produce 2.8 volt to 4.2 volts. But this voltage is not enough for all the modes of operation of the pacemaker. So a converter is required here. So the converter used here is a DC to DC converter. So the DC to DC converter, the purpose here is this battery voltage has to be stepped up, or we can say boosted up to 5 to 12 volts. And the power consumption of this pacemaker is 10 microwatts to 100 microwatts. And the next is the implantable cardioverter defibrillators, which is to prevent sudden cardiac arrest. It uses a battery voltage of 3.2 to 4.2 volts, and this voltage has to be boosted up to 200 to 1000 volt in order to provide shocks. And the power consumption is 100 microwatts for monitoring and up to 10 watts for shock delivery. And the next one is neurostimulators, which is the purpose of this neurostimulator is to stimulate the nerves. And the battery voltage in this device is 3 to 4.2 volts. And the converter in this has to boost this 3 to 4.2 volts to 5 to 15 volts. The power consumption is 100 microwatts to 10 milliwatts. And for cochlear implants, which is used to restore hearing, the battery voltage required here is 3 to 4.2 volts. And the converter will boost this voltage to 5 to 10 volts. And power consumption is 10 milliwatts to 100 milliwatts. So as we discussed all the types of implants listed here, the converter plays a major role here in order to boost the battery voltage. But not only the converter will boost the voltage, it also buck the voltage. It means step down the voltage. So the purpose of the converter in a biomedical device is to step up as well as step down the voltage. But whether to step up or step down depends upon the mode of operation of the biomedical device. Like whether it is going to monitor the signals, or it is going to provide pulses. Say, for example, it is going to deliver a shock delivery, or a pacemaker is going to provide pulses to regulate the heart rhythm. So depending upon the mode of operation, the converter will boost the voltage or it will buck the voltage. Now, these are various DC to DC converter topologies. We have buck converter, which is step down converter. So it means the output of the buck converter will be less than the input voltage. And these are used in pacemakers to step down battery voltage for microcontroller operation. And boost converter, whose output will be greater than the input voltage. So we call it as step up converter also. And it is used in wearable defibrillators to charge capacitors for high voltage discharge. And next is the buck boost converter. So this converter actually does both the operation of buck converter as well as the boost converter. So this is useful when battery voltage varies with the discharge. So depending upon the requirement, whether the voltage will be buck or it will be boosted. So the next is CUC and CEPIC converters. It is preferred in low noise biomedical circuits. So the CUC converter actually it inverts the input voltage, and the CEPIC converter without inverting the input voltage, it will either buck or boost the voltage. Next is the switched capacitor or charge pump converters. So this is actually ideal for implantable devices due to their small size, low electromagnetic interference, and no magnetic components. So here I have listed the various parameters of all these converters. So for starting with the buck converter, which lowers the voltage, the efficiency is high and it has moderate electromagnetic interference, compact in size and low noise, and it is suitable for pacemakers, microcontroller power supply. And boost converter, it increases the voltage, which is having an efficiency of moderate to high electromagnetic interference. Size is medium and moderate noise, and suitable for wearable defibrillators, sensor excitation. And next is the buck boost converter, which actually, as I said earlier, it raises or lowers the voltage. So efficiency is moderate, high electromagnetic interference. Size is medium and noise moderate to high. And the suitability is variable battery levels, wearable monitors. Similarly, CUC converter, it inverts the voltage. So output voltage will be, the input voltage will be inverted at the output stage. So the efficiency will be moderate, low electromagnetic interference, and size will be bulkier because the reason is due to the presence of inductor in it, and very low noise, and it is suitable for low noise circuits, signal conditioning circuits. Next is the CEPIC converter, which actually will not invert the input voltage. So the polarity of the output voltage will be same as the input voltage. So the function is to step up or step down, and the efficiency is moderate, electromagnetic interference is low, medium in size, and the noise is low, and suitable for biomedical data acquisition systems. Switched capacitor or charge pump converters, which are nothing but DC to DC converters. It is also a type of DC to DC converter. It boosts or inverts voltage using capacitors. So this actually, this charge pump converters uses capacitor for charging in the place of inductors. So this is the reason why the size of the charge pump converters are very small. So the efficiency, but the only drawback is the efficiency is moderate, that is 70 to 85%, but electromagnetic interference is very low. The size is very small. This reason why these type of converters, that is the charge pump converters, are used for implants, biomedical implants. So the noise is also low, and the suitability is implantable like pacemakers, neural implants. Now let us just look into the basic operation of buck converter. The DC to DC converter, if you consider, the basic converters are buck converter and boost converter. So, and the next buck boost converter is a combination of buck and boost. So the buck converter actually, as I said earlier, the output of the buck converter, the V out will be less than the input voltage Vs. So V out will be less than Vs. So let us look into the operation of the circuit. So it has a switch S1. The switch is a controlled switch. It can be a MOSFET, IGBT. So any such controlled switches, and a freewheeling diode, an inductor, a capacitor, and a load resistor. Now, the operation of the circuit can be seen in two modes. One is, the mode 1 is when the switch is on, mode 2 is when the switch is off. So let us consider first the mode 1, that is the S1 is on. So when the switch S1 is on, so the supply current starts flowing through S1, through the inductor, and through the load resistor. So across the output, we get the input voltage. So the V out will be equal to Vs. But what about this freewheeling diode? Why the current is not flowing through the freewheeling diode? Because it is reverse biased during this condition, as the positive is connected to the cathode and the negative is connected to the anode. So the freewheeling diode is reverse biased. No, the current only flows through S1, L, and the load resistor. Now, the mode 2 is when the S1 is off. So when the S1 is off, the Vs will not flow through the circuit. No input voltage will appear across the output. Why? Because the switch is open now. So what happens now? The output voltage, actually when the S1 was in on condition, the current flows through the inductor. No, so the inductor would have stored the charges. Now, when the S1 is off, there is no supply current connecting to the load resistor. So what happens? The stored charges in the inductor will get discharges. It discharges. The inductor discharges. So what happens? The discharged charges will flow through the load. It will circulate through the load resistor and the capacitor. So no, the V out will be actually less than the input voltage, because only during S1 the input voltage appears across the output, and during S1 is off, the Vs does not appear across the output. Only the stored energy in the inductor appears across the output resistor. So that is why the V out is lesser than the Vs. That is why we call this as buck converter. So the buck converter is otherwise known as step down converter. So wherever we need lesser voltage than the input voltage, we can use this buck converter. Next is the boost converter. Here actually the same components are used, but only the positions are replaced. Here, again, here the circuit operation can be considered in two modes of operation. One is when the switch is on, and the second operation is, second mode is when the switch is off. So first, when the switch is on, the input current actually flows through L. As the switch is closed, the current flows through the switch. So all the input current flows through L and the switch. So what happens? The inductor charges during this period. That is, when the switch is on, the inductor charges. It stores energy in it. Now, the next mode of operation is when the switch is off. So when the switch is open, so this leg is open. So what happens? All the input current flows through inductor, through the diode, and through the load. Now, when we apply Kirchhoff's voltage law for this, we can understand that the output voltage will be the sum of Vs, that is Vs plus the voltage across the inductor. That is, if we consider the voltage across inductor as VL, then Vs plus VL will be V0. So V0 will be greater than Vs. That is why we call this as step-up converter or boost converter. Why? Because the V0 is greater than Vs. So whenever we require greater voltage than the input voltage, we can choose this boost converter. So these two, buck converter and boost converter, are the basic converters of DC to DC converters. Now, this is a special type of DC to DC converter, which is charge pump converter. So why discussing? The purpose of discussing this charge pump converter is there is future research scope when we are going to change the material used for the converter switches. We can reduce the size, as well as we can do the research can be done on improving the efficiency of this converter. As I was discussing during the previous slides, the advantage of this charge pump converter is the size is very small, so this is suitable for implants. But the only drawback is the efficiency is moderate. It is 70 to 80%. So the research can be done or focused on improving the efficiency of the charge pump converter. So why the size is small here for this converter is if you look at the component, there is no inductor here. So this converter uses capacitors for transferring the charges from the input to output, replacing the inductors from the conventional converters. So let us look into the operation of this converter. Actually, it uses two capacitors. So we can even increase the number of capacitors. So we can call that as interleaved charge pump converter when you're going to increase the parallel capacitors. So here, actually, the input voltage, when the input voltage is applied, the current starts flowing from the input through D1, through D2, and through the load. So during this time, the capacitor C1 charges, as well as the capacitor C2 charges. Now, when the current flows through D1, the capacitor C1 charges. So the positive terminal of the capacitor is connected with the diode. So suppose if Vin is 5 volt, the capacitor C1 will charge us up to 5 volt. We can neglect the drops. Suppose if we consider the drop also, maybe the capacitor may charge up to 4.7 volts. Now, the negative terminal of the capacitor is connected to a pulse input. So when we give pulse to the negative terminal of capacitor, so when the pulse rises from 0 to maximum, so a positive pulse is given to C1. So what happens now? Already the C1 is charged to some 4.7 volts, considering the drop. Now, when you give a 5 volt of pulse to this negative plate of the capacitor, what happens? This 4.7 plus this 5 volt, 9.7 volt will be pushed to the D2, and this capacitor C2 will be now charged with this 9.7 volt. So we are applying only 5 volt as input, but we are getting nearly 10 volt as the output. So we can say this charge pump converter even as a voltage multiplier, because it will be double of the input voltage. So here in this circuit, the 2 capacitors are used. So one capacitor for that is for charging, another one C2 is for pumping the voltage to the load. So the charge pump converter actually transfers the input charges to the output by using the capacitor and replacing the inductors with capacitors. So that is the reason why these converters are small in size. So the current state of the art at international level is self-powered implants using body heat. And next is ultra miniature buck boost converters for tiny medical implants, high efficiency switch capacitor converters for neural implants. And the advancements in India is high power DC to DC converters for biomedical and industrial use. So we are going to concentrate on self-powered implants using body heat. The reason is actually even when we consider all, say suppose electric vehicle also, if you're going to consider, the major problem associated with electric vehicle is the battery. So everywhere, whenever we go for any modernization, again, the battery is going to be the problem. So the self-powered implants replaces the battery. So how? The self-powered implants using body heat actually converts body heat into electrical energy. It uses the phenomenon of it is based on Seebeck effect. So the self-powered implants using body heat actually rely on thermoelectric generators, which is based on Seebeck effect. The Seebeck effect is the phenomenon in which voltage is generated across 2 different conductors or semiconductors when their junctions are maintained at 2 different temperatures. Here in the image, you can see one junction is maintained at cold temperature and another junction is maintained at hot temperature. So when the 2 different junctions of the materials, the semiconductors are maintained at 2 different temperatures. So what happens? This actually causes the electrons to flow. So because of this, the current starts flowing, which supplies the implant, which supplies the device. So our motive is to replace in place of the battery. See, actually all the implants, if we consider the pacemaker, so the pacemaker rely on the battery. So it is going to be placed inside the human body. So after a few years, say we all are using lithium-ion batteries. So it may be the lifetime, maybe 10 to 15 years. So after 15 years, if we consider the maximum lifetime also, if after 15 years, we have to go for, we have to replace the batteries. So we, instead of, we can avoid this surgical procedure if we are going to go for self-powered implants using body heat. Because it will, what the self-powered implants will do is, always the pacemaker will be, continuously it will be supplied with power with the help of the body heat. So it will not rely on the battery actually. So as I explained, it is based on the Seebeck effect. Now, so what we can concentrate is the future research scope for this is advanced thermoelectric. We can focus on advanced thermoelectric materials the goal is to improve conversion efficiency at small temperature gradients. So we can concentrate on materials with high Seebeck coefficient and low thermal gradient, low thermal materials we can choose, and also we can go for high Seebeck coefficient materials can be used in order to improve the conversion efficiency at small temperature gradients. And we can focus on hybrid energy systems. The goal is to combine the thermoelectric generators with piezoelectric or RF energy harvesting, which are the other sources of energy. And we can focus on power management and storage, which ensures continuous operation. So the future research can be for biomedical devices can be done for the improving the efficiency of charge pump converters. And also we can concentrate on the self-powered implants using body heat, so which has more scope in doing the research. So if any questions, it can be asked now.
Good evening, ma'am. This is Dr. Madhu Sharma from Haridwar, Chinmay Degree College. I am director and assistant professor here. My question is that, ma'am, what are the drawbacks of using body heat in self-powered implants?
Ma'am, it is biocompatibility of the material.
Ma'am, like every whatever we are using in the body, so it is using body heat. So what will be the bad effects? Is there any studies has gone over on this?
Actually, studies is actually it is not yet implemented. It is the research is undergoing. So the concept is the thermoelectric generators. I said that it is based on Seebeck effect, so it need two different temperatures. So the one side of the thermoelectric, that is TEG, will be focusing on the body temperature. Let's say suppose 37 degree. That is, and the other side of the TEG will be focusing on the external skin of the body. So we will have some few degree difference in the temperature. So this small temperature difference will be used for generating the voltage, which creates current when it is closed loop. So which supplies the device implant. But the problem in this self-powered implants is very low temperature difference. So that is where we have to concentrate, and research can also be done with choosing the material, which can, with a low temperature difference also, if it is going to produce or generate voltage, it will be the future scope of research.
Thank you very much, ma'am.
Yeah, Dr. Renuka Devi, it was an excellent presentation.
Thank you.
On power electronics, especially because that's one of the areas that least spoken. Only those who are involved with the industrial controls, instrumentation, and they're involved. It's very informative. I have one question about the thermoelectric generator. We're using the body temperature difference.
Okay.
Typically, well, in our body, how do you run the conductor, the wire, external to the body or internal to the body? Somehow they weave the conductor.
No externals, sir. Actually, these are implantable devices. So we are talking only about the implantable biomedical devices. So no external probes or no external.
So, right, but somehow, in order for power to generate, you have to run a conductor. There got to be a conductor. So if it is if it is the same part of the body, then temperature difference is not a whole lot.
Yes,
but
sir.
If you take the temperature difference from, for example, feet, usually it is cooler, compared to when we come up to the body, it is warmer. So any event, selecting two points of bigger voltage difference, but the challenge there would be running the conductor through the body. And then supply the power to the biomedical instrument, the device,
Device.
such as a maker, whatever you can, because after all, that requires power. So you can boost it. I don't know if that is practiced or not. I don't know.
No, it is not practiced, sir. It is under research.
Under research. Okay. Yeah, very interesting. The way you showed the RLC circuits. That took me back to my previous life when I got a bachelor degree in electronics and communication engineering and a master's in electrical engineering. And I worked in the electronics area, electronics, I should say, in the beginning of my career for about 15 years. So it was so thrilling and refreshing to see the receiver presentation that took me back in my life and kind of refreshed me and brought me somewhat up to date with my knowledge. Thank you so much.
Thank you so much, sir.
Extending to the comment by Dr. Sharma, see, the problem is in biomedical applications, a lot of times we use toxins. Particularly, let us say, as a stint in the heart, we use a material called nitinol, nickel titanium alloy. Nickel is carcinogenic, but the dissolution of nickel is so, for over a period of time, it may be considered. But a patient life extension and to the risk of this carcinogenic material in the body is weighed together. If an ethanol can extend the life for about 10 years, in fact, a lot of stints these days, they if it's perfect, suitable stint, can be successfully used for up to 20 years, more than 20 years. So that is where we have to make a balance. No, nickel is a toxin. In fact, the girls, children, they wear nickel jewelry. Some kids immediately get infected because of that nickel-ion interaction. They may not tolerate it. And saying that one, people are not stopping wearing nickel jewelry. So it is a balance between the life expectancy, extension of a patient to the possible scenario of this toxic ions entering into the body. So that is it's a very interesting. In fact, when I teach this biomedical for medical students, this course, this is one of the important points. So there is an inbuilt mechanism for the risk involved in this one. Second, his comment, when she is talking about sensors in the body and conductivity and all, please don't imagine like ordinary electronics. In the body, the implants are completely different. Their behavior is different. Conductivity is there because blood is there. Blood is salt is there. So the conduction. So inside, electrical conduction is not a problem at all. So the mechanism does not work like a regular electrical engineering applications. And once they put some, either even sensor, once they put a sensor, let us assume, for the Alzheimer's disease, So if the patient shakes, immediately that sensor triggers because of that vibration. It triggers a counter vibration in the brain. As automatically that is shaking stops. So whenever we have an inbuilt implants, there is a mechanism how it will start, how it will stop. The only thing valid point is, in fact, of course, people do take consideration of corrosion of this material. I mean, like she's talking about lithium-ion batteries. So they take care that nothing leaks out of it. If lithium material is in contact or leaks into the body, it itself is really bad. So all those for application in the biomedical instrumentation, the packaging takes care of everything. And as far as connections are concerned, automatically they take the help of the body fluids to make as a conductor. So that is my just 2 cents of comments. It's a very good presentation, very important eye-opener for everybody. In future, in fact, that is how we are going to have our life extension. In fact, the theory says we can extend life even up to 300 years. But ethics are different. I mean, what is the purpose of living 300 years of life? That's another story. But it's an excellent presentation. I hope Dr. Sharma's.
Thank you, sir, for added.
Sorry. Oh, I have muted.
Thank you for the added information, sir.
Okay, that is good. But I hope Dr. Sharma is satisfied with my answer for her question about this toxicity. That is what she was concerned about, right? She asked a question.
Yes, sir. I got my answer. Thank you.
Okay, good. Okay, that's good.
Thank you so much, sir. Thank you, Madhu ma'am. Thank you, Renuka ma'am. I request anyone from the participant side, if you have any questions, please ask Renuka ma'am. And we can discuss also, because here a very good discussing platform happened because of 2 stalwarts present over here from USA. Srinivas Rao sir and Prakash Rao sir, they are very good at all these subjects. So we can make some discussions also. I request anyone from the participant side. Sir, you are in mute condition, sir.
No, somebody seems to have asked a question. They have to speak a bit loud. I can't hear. That's what I'm saying.
There was a background thing, Om Namah Shivaya. Somebody said that came through.
No, sir, that is my actually notification ring tone, sir. Whenever I got any message, Om Namah Shivaya.
Oh, okay, I got it.
Sorry, I forgotten to make it as a silent mode. Sorry. Sir.
No, I think it was good. It was a blessing. An icebreaker.
Okay.
So.
I request anyone to please speak a few words, because we have time now and we have an opportunity also to discuss on this platform and to explore ourselves and to the gathering also.
So I have a small question for Dr. Renuka Devi.
Yes, please. Sir.
While I ask the question, others may think.
Yes, sir.
The question. So for the implementation of these circuits, in these devices. They use ASIC. I'm sure they use ASIC, there's no doubt.
Okay.
Because it's more than just the RLC circuits. So are there any companies in India or abroad who make these ASIC chips? And any universities, do they have any ties with them for extending the research concepts or taking into industry or experimentation?
Actually, I'm not sure about this information. So, I was discussing about this because this research proposal, this itself is my research proposal, which I have submitted. And I'm concentrating on the designing a converter with more efficiency. So to improve the efficiency, and already it is compact in size, the charge pump converters. And my research focuses on to improve the efficiency and to reduce the electromagnetic interference. So I thought this would, I didn't focus on the materials. My research work is not on the materials, so I didn't focus on that. But later I'll think about this also.
Right. Because I do see that there is one. There are also inductors there. So that's what you are referring to, EMI. So yeah, but that is such a low level of emission.
Yes.
And also that emission will be of higher strength only when there is more current. Otherwise, it's not so. And
actually, these charge pump converters, they don't use inductors, so only capacitors to transfer the charges. But we can even add the inductors along with capacitors to improve the efficiency. That is one way of improving the efficiency. But the again drawback when we add inductor is the size again size will increase.
right.
So our our goal is the implants need converters with small, which are already the implants are very small. So we need converters which are micro in size. So if we add inductors, it will improve the efficiency, but the size will increase. So without adding inductors, we have to focus on the research to improve the efficiency.
Right, it's bulky, so yeah, that makes sense. Okay.
I did not really understand the question correctly. Is it your intention to ask a specific sensor or whatever it is, biomedical instrumentation availability, or general bioimplant materials? Because unless the question is specific, you can't.
Yeah, it is a specific question on one of the slides.
Those who are interested, they can just go into Google, whole series will come. And in fact, you have instrumentation from the sensors for different diseases and pacemakers, different materials for limb movement, start shaking. All those things are available in the market, including synthetic blood. In fact, they make blood out of iron cells. All those things are available in the market. So I think it is better.
My question was very specific and related to the material presented, and it even referred to a slide that showed inductor that I was asking about. So it is very specific. It's a relevant question. And that was one of the slides in the beginning. It's very specific to the presentation only, not outside. And that was the fourth or fifth slide, where it was a converter stepping up the voltage. So yeah, this is purely electronics related one. And so this is not about a system level outside external, Dr. Srinivas Rao. Yeah, there we go. One of the, please show that one that showed inductor, the RLC circuit with inductor. After all, this is the implementation what's inside a biomedical device. Yeah, this is the implementation, electronics implementation inside the biomedical device. So that's what this is. This whole presentation relates to, as I could see, that they're using power electronics, how to step down the voltage, step up the voltage, how to boost current when needed, how do you do it, switching, kind of a thing. Hope that clarifies. Thank you, Renuka garu.
Yes, sir. Thank you. Any more questions?
Ma'am?
Ma'am, any more questions?
I request from the audience side, any more questions to ma'am? Yes, ma'am. Thank you so much, Renu ma'am. Thank you.
Thank you so much, ma'am.
Thank you.
For this opportunity, because actually, as this is my research proposal submitted to my to our university, so I think I got more area to again think over for this after discussing with the great people.
Yes. Thank you, ma'am. Thank you so much. Thank you.
Thank you, sir.
Yes, ma'am. Yes, ma'am. Please continue.
Yeah. Thank you to all. Sir.
Actually, we are about to have one more session, ma'am. If you have time, you please be with us for that session also. And one more thing, ma'am, actually, from the inception of this FTP, we are announcing daily 3 things to the resource persons. First thing is whatever the lecture delivered by the resource person is going to be published in our peer-reviewed journal, International Journal of Science, Engineering, Arts and Management. In this connection, I request you to please make a paper on your talk, ma'am. So we are about to publish your paper in our journal. And
can you mention the journal name, ma'am?
Journal is our own journal, ma'am. That is a peer-reviewed journal, International Journal of Science, Engineering, Arts and Management. I'm about to send you the details also, ma'am.
Yeah, okay.
To your personal.
Because I have already prepared a literature review on this.
Yes.
So you send the journal name, ma'am. I'll look into it.
Sure, ma'am. Sure, ma'am. And second request from our side is, if you could please send 5 to 10 MCQs, multiple choice questions of your talk. So at the end of this FDP, we are about to make a testing program to all participants. So we are about to make a Google form also with the questions from all the resource persons, ma'am.
You want the questions as a Google form, or if it is in a Word format?
Just in the Word file you can send, ma'am.
Okay.
We'll make the Google form.
Okay.
Or you can type in your WhatsApp and you can send to me also. I'll make the necessary.
When you need it, ma'am?
Actually, tomorrow only the last day, ma'am. So maybe by tomorrow evening, if you could able to send, so we'll make a form and we can give it to all participants on Sunday, because tomorrow also we need to complete 2 more sessions. So they will be sending by tomorrow night. I don't know. So that's why.
I'll send by tomorrow. Before
Yes.
tomorrow, I'll send.
Yes, ma'am. Thank you so much. And the third request from our side is, if you could able to join tomorrow also for a while. So all the resource persons are at once we are meeting, ma'am. And thereby all the participants, if they have any doubts later on, they can be noted down and they can ask the resource persons, and we are all can meet once itself. So tomorrow for half an hour, all the
At what time, ma'am?
ma'am, it's most probably by 7:30 to 8. Actually, 8 o'clock we are completing the session. So 8 to 8:30 we are planning, ma'am. I'm about to send a invitation also for tomorrow's session to all the resource persons.
Okay.
I'll send a invitation message also, ma'am.
Okay, ma'am. I'll join. Ma'am.
Yes, ma'am. Thank you, ma'am. Thank you so much. Thank you.
Yeah, okay. Can I leave, ma'am?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Ma'am, 1 second.
Kaustubh sir,
Yes, sir.
welcome.
Ma'am, good evening. I'm very sorry.
Good
Actually, just now came from the college. So before madam will leave, just I want to say my thankfulness to the ma'am. So, ma'am, Dr. Renuka Devi, ma'am, really we are very thankful. In the short span, actually you have prepared yourself and then you have presented the session. Actually, since all the presentation and all those things will be in recording mode only. So even though if we are missing out some sessions, so we are watching it. Okay, ma'am. So thank you so much. And really we are thankful. So hopefully from here onwards, our collaboration will go ahead. And we are looking for many more upcoming events, many more upcoming conferences. So I actually here our ma'am is there. So Professor Dr. Aruna ma'am, so she will be always briefing and giving the details. Okay, ma'am. So looking forward to go ahead in future also, ma'am.
Thank you so much, sir. And I'm also interested to collaborate with your institutes.
Thank you, ma'am. Thank you so much.
Definitely, I'll come and meet you, ma'am, at Kanchi, because I'm very fond of coming Kanchipuram. So to
ma'am, you're welcome. You're welcome. No, you're welcome. Most welcome to Kanchipuram, ma'am.
Yes, ma'am. Thank you, ma'am.
It's a temple city and famous for silk sarees. And
yes, ma'am. Yes, ma'am. Thank you, ma'am. Thank you so much.
Thank you so much, ma'am.
Thank you. Kaustubh sir,
ma'am.
Ma'am also the second person.
Dr. Mamta ma'am, right, ma'am?
Yes, ma'am. Yes, sir.
Okay, so should I say her to join?
Yes, sir. Yes, please, sir. Yes, please.
Okay. Okay, ma'am.
Meanwhile, I request any of the participant side, could you please give your inputs also or suggestions or any lapses you had found in these 6 days? Anything you can talk here. We can take it as your great suggestions and advices, and we are about to implement in our upcoming conferences. I could see here daily Bhavana Srivastava, ma'am. If you are there, ma'am, could you please speak a few words? Meanwhile, our next speaker join. Bhavana Srivastava, ma'am. Deborah. Here, I could see some names daily they are joining. Dr. Gandhi, sir. Dr. Nagamani Kumar. Renu Kumari. This means you are not able to speak or you are not there in the meeting. Just keeping the keep logging and you are going away from the meeting. Trupti Kot. I request Trupti, ma'am.
Hello, ma'am.
Yes, ma'am. Yes, ma'am. Please.
Good evening, all of you.
Good evening, ma'am, please.
Yes, ma'am. I am attending these FDP sessions from first day. Very useful talks. It was very grateful to have such wonderful personalities. It is very useful for our future research also. Thank you, ma'am.
Thank you, ma'am. Thank you so much. I could see you daily. That's why I had announced your name. Thanks a lot for learning something from all these stalwarts, whomever giving their valuable talks on this platform. Thank you, ma'am. Thank you so much. I request Shashikant Lab, sir. Shashikant, sir. Okay, sir. Gandhi, sir, no problem. Tomorrow you can speak, sir. As you are unable to speak now, you are in journey. As usual, Madhu Sharma, ma'am, very active person in this FDP daily. I could see, ma'am. Thanks a lot. I also learned a lot from you, ma'am. Your interest and your sincerity and time management and time sense also. Exactly, you are joining and up to the last, you are being a senior person itself. You are having all the sessions, ma'am. Thank you so much, ma'am. Thank you. I think Dr. Manisha, ma'am, said about this thing to you, I think. And
Yes, ma'am.
first of all, ma'am also very cooperative with me since last 5 years, ma'am. Dr. Manisha, ma'am.
Ji, ma'am.
Thank you, Dr. Manisha, ma'am. And thank you, Madhu Sharma, ma'am. If you wish to give any suggestions or any advices, it is welcome, ma'am. Thank you, ma'am. Thank you so much.
Ma'am, all the sessions are very informative. I want to say that in the feedback form, after any participant has filled up, we must get the email after filling whatever we have filled.
Okay, one copy you also got, ma'am. That's
Yeah.
not interesting. Actually, we had given name, phone number, and email ID of the participants itself. What else you are saying, ma'am?
Ma'am, in the feedback form, after filling feedback form, or I must say after submitting the feedback form,
Yes, ma'am.
one must get the email of the responses, what we have filled.
Oh, okay, ma'am. That option we had not at all, not
Yes,
at when,
yes,
ma'am. So finally, tomorrow, the compilation of all these sessions will give one final feedback form, ma'am. So that time I'll do this, ma'am. I'll implement this.
Thank you, ma'am.
Thank you, ma'am. Thank you so much. Thank you for your advice.
Because this is a Google form, it directly goes to a Google Drive, right?
Yes, sir. In my mail
doesn't-
ID, it will come as an Excel sheet, sir. All the responses, it will come as an Excel sheet. Yesterday also, you had asked this question. I am unable to answer that time.
Right. Sure.
Once after filling this form, whomever prepared that Google form through one mail ID, they will be getting one Excel sheet with all the responses, with all the information.
Right. So these responses submitted, are they visible to everybody, or only to the person who submitted and the administrator? Are they visible to everybody?
No, sir. No, sir. Only the person who had given this Google form, to that person only all these things will be visible, sir.
Okay. Good.
Thank you, sir. Thank you so much.
Ma'am,
Thank you,
good,
Madhu, ma'am.
good
you,
evening, ma'am. Actually, our next guest and speaker, Dr. Mamta Bhardwaj, ma'am, has joined.
Yes, sir. Yes.
So let's begin there. Ma'am, Dr. Mamta, ma'am. Good evening, ma'am.
Good evening, sir.
I request Kaustu Kumar, sir. Are you able to introduce ma'am, or shall I introduce?
Ma'am, actually, if you will introduce, it will be better, because if
Sure.
I will start introducing, the complete FDP will become like a introduction about ma'am, because at the end I will tell how legendary she is and what are the good work, social work, and what are the contributions he is doing in the teaching field, ma'am. So at last, that time I want to save after presentation of ma'am, I will tell.
Sure,
So
sir.
it's
Thank you, sir. Thank you, sir.
ma'am,
Thank you.
it's really a privilege for telling yes for this FDP, because I can understand how much you are busy. So thank you, ma'am. Ma'am, you please proceed.
Thank you, Mamta ma'am, first of all, for accepting
Thank you. Thank you so much, ma'am. Thank you.
our proposal and our invitation to be as a resource person for our 1 week faculty development program, ma'am. Thank you so much, ma'am. We are very fortunate enough to have you, ma'am, in this auspicious session. And in this juncture, I wish to welcome my heartfully Dr. Mamata Bharadwaj, ma'am, as a speaker, distinguished speaker to this session. And if we could come to her short bio, ma'am currently is working as assistant professor, Dronacharya Group of Institutions, Greater Noida, Uttar Pradesh. And ma'am's department is Applied Sciences and Humanities. And she had obtained her PhD in biological applications of organometallic compounds at Meerut College, Meerut in 2010. And she has published papers in various national and international journals. Her areas of interest are nanotechnology, green chemistry, and organometallic compounds. Ma'am, very interesting subjects you are dealing now, ma'am, and your expertise. I wish this FDP will be flourished with your expertise, ma'am. Thank you so much, and over to you, ma'am.
Thank you. Thank you so much, ma'am. Shall I start, ma'am?
Yes, ma'am. Yes, ma'am. Yes,
Okay. Okay. My screen is visible to you, ma'am?
yes, ma'am.
Yes, ma'am.
It is
It is
visible.
Okay.
visible.
Okay. Video. Good evening, everyone. Before I start, I would like to give you some food questions, food for thought. Every year, many extraordinary students are forced to take up a stream they don't want to study, being forced to study science instead of their true calling. My second question is, many students with a lot of potential not being able the level of education they deserve due to financial crisis. So this is our loopholes of traditional education system. Just because of finance, they cannot continue their education. My next question is, students from rural areas not having the awareness about online schools and now being 2 years behind their colleagues or their friend group. My next question is, a student with exceptionally academic performance not getting placement due to lack of multidisciplinary approach. These are not hypothetical situations. This is the reality of our education system. That's why it is necessary to reimagine our education system. It is both a privilege and a necessity to speak today about something that concerns us all, the future of education. Today's topic is reimagining education, the multidisciplinary imperative. And theme is the future is interconnected. Why interdisciplinary matters? So the theme given by our Honorable Prime Minister Sir, One Earth, One Family, One Future is a powerful reminder for us. It is interconnectedness of all life on Earth and need global cooperation to address challenges facing our planet. More specifically, the urgent need to reimagine it, not as a patchwork of outdated methods, but as a bold, forward-looking multidisciplinary ecosystem. Let me begin with a simple question. Are we truly preparing learners for world they are stepping into the world we ourselves grew up in. The 21st century is not defined by a single discipline. It is not just the age of artificial intelligence or biology or physics or chemistry or art side. It is an age of intersections where climate change needs both science and policy makers, where innovation demands both engineering and ethics, where leadership requires both data and empathy, not sympathy. The walls between subjects are crumbling, and so must our rigid education system. So these are some loopholes of our education system. That's why it is the need of hour to change our traditional system to advance one, according to the need of 21st century. So first start, what is the etymological meaning of reimagining education? The concept of reimagining education is about transforming the way we think about learning, teaching, and purpose of education itself. It challenges the outdated industrial era model of schooling and envisions a system that is learner-centered. In our traditional system, what we are doing, only a senior person, or we can say mentor or the teacher, just giving the knowledge in a one single channel. The students are not supposed to allow to interact or interrupt the faculty member. Future ready, inclusive and holistic development. Reimagining Indian education system means breaking barriers between the disciplines. In short, reimagining education is not an option, it is a necessity of us. If we want to raise empowered individuals who can lead, innovate, and solve world problems, then our education system must evolve with the world around them. According to classes, if we are going to change, or if we are try to
Ma'am, sorry.
reimagine the...
Ma'am, sorry to disturb you. Your slides are not moving, ma'am.
Okay. Sorry, ma'am. Sorry. Yes. Sorry. The online data shows that means if we are not sitting in a four walls room, inside the room we are trying to getting the education. If we are broaden our horizon, if we are trying to convert a traditional system that is offline mode into the online mode, so what give us online retain 25 to 37% of total market. By online, 15.8 million jobs are in India only. And imagine the condition if you are living in rural areas, and suppose I am the mother of 2 children and I am living in rural areas, my financial condition is not good and I am fit enough to earn money. So in traditional era, it is not possible to earn money. But in the 21st century, we are ready. In our rural areas, approximately 15.8 million jobs has been created, and they are earning a number of surplus amount of money, and including this 15.8, 3.5 millions are women. In US, 14% of workplace are roughly 22 million people work from home. In India, 12.7 of full-time employee work from home today in India. And in our education system, the students who are not able to take education, if they are living in their hometown or they are facing so many medical problems or financial problems, 70% of students say an online learning is better than traditional classroom learning, because it is the inception, it is the initiation of multidisciplinary approach, or you can say digital education. 30% of students in US engage in online activities. And I am very much sure and I am feeling proud to interact you. I am living in Ghaziabad and I am interacting you all. So this is also a blessing of digital education. Online learning has grown 900% since its inception. So we are living in GPS era. Okay, to find our way around town, to get our destination without getting lost, and to make sure we are on time for our appointments. Why this reimagination of education system is essential? Why we want? We want to reimagine the education system because the world changed, that our traditional system hasn't kept us. Here are the reasons why reimagining education is necessary. First, mismatch between education and real world needs. Today's education often emphasizes rote learning over critical thinking, creativity, and problem solving. Many students graduate without the skills demanded by modern industries like AI, climate change, and entrepreneurship. In today's era, the students are being passed by flying colors. They are getting 9 CGPA or 9.5 CGPA, but they are not able to take placement. So this is the loophole, this is the problem, and that is the requirement, that is the need of reimagine the education system. Second, why reimagination is required for our education system? One size fits all doesn't work. That is, every learner is different. You, me, I, and everyone is different. Okay, so education should be depending upon the personal interest. Education should be depend upon the mental intelligence or emotional intelligence. One teaching method cannot suit to another, our sibling or our classmate or anyone. So every learner is different in pace, interest, strength, and context, but the system treats them all the same. In a classroom where 60 students are sitting, only one member is delivered the content. What he is trying, what she is trying to complete his or her syllabus right now. He or she is not bothering what his or her students are working. Shall they grasping the content or not? No matter what. So one size cannot fit to all because every individual is different from each other. So it is a time to reimagine the education system. Next is lack of multidisciplinarity. Real world problems are complex and require knowledge from multiple domains. Education must go beyond silos. That is science versus arts. That is embrace the sustainable development requires science, arts, and our policy also. Next point is, next requirement is technological revolution. We are living in the digital era. So we live in digital age, but many schools still operate like they did a century ago. Can you imagine? 70% of Indian schools, I am talking about the primary schools, were unaware in the pandemic era. They are not getting education. The faculties are not very expert to give or deliver the education. If anyhow they are ready to deliver their content to the students, they don't have resources to deliver the content in the pandemic era. So in my sense, the pandemic era was the real situation who ready to reimagine our education system. So technology have enhanced access, engagement, and adaptability if used wisely. Next point is, if we are talking about one earth, one family, one globe, the global challenges needs global thinkers. Issues like climate change, pandemics, inequality need global citizens with empathy, ethics, and collaborations. Next, why reimagining the education system? Mental health and well-being. The current system often prioritizes make over mental health. A future-ready education must nurture emotional intelligence, mindfulness, and well-being, which were lacking in the traditional system. Next, important criteria is multidisciplinary approach. So what is multidisciplinary approach? A multidisciplinary system prepares students for a dynamic, not lethargic, global future. India must act now to create lifelong learners, not just exam takers. In short, a multidisciplinary education prepares a student not just to master the content, but to navigate a complex, interconnected world with agility, insight, and purpose. Integration of knowledge across discipline. So it is very essential to integrate between science and art. This is a taboo in our society. And always the science students have an advantage. I am the science student and I am the intelligent one. But it is my thinking, and it is the data shows that all the students who are the mediocre students or having the human values or having the arts subject like political science, sociology, they are the master of the world. So there is a blendedness between the technology and ethics, encouraging holistic thinking, problem solving, and innovation. Moves beyond memorization to understanding and application. So whatever is written in book, we are delivered the same. We are not ready to accept the loopholes. What students are getting this or not? What we are doing, we are giving the syllabus and students are getting the same and they are omit the same in the examination room. So that's why this is the need of our education system, or it is the need of reimagine the education system via multiple approach. And it is very important. Some examples I want to discuss in engineering, because my background is, I am from engineering background. So in engineering, what we are doing, we have divided the entire content into so many types of engineering. We have computer science engineers, we have electrical and electronics engineers, we have mechanical engineers, and all are very much separated. After completing first year in common classrooms, they are divided to their respective branches. There is no correlation between them. But I personally need combining core technical skills with insight from economics, environmental science, design and aesthetics, sociology and ethics, business and management. For example, I want to discuss the case study number 1, electrical vehicles. So it is a need of hour to think about the alternative of energy resources. For fossil fuels, which includes coal, oil and natural gases, are non-renewable sources, meaning they will eventually run out. So we have to think about alternative which are renewable. So if I am thinking about the electrical vehicles, it requires knowledge of electrical engineering. So only an electrical engineer can develop the electric vehicle? No, never. Because a collaboration is required. And the primary collaborators are electrical engineers plus environmental science plus public policy. It can vary from country to country, it can vary from state to state, but the collaboration is required. Multidisciplinary approach is required in our engineering system. Smart infrastructure. If I want to build a smart city or smart appliances, so it needs collaboration between civil engineers, scientists, and urban planners and all. So that is the need of R. Now, I want to discuss some very eminent multidisciplinary personalities. The personalities which never ever bound in boundaries. They think, they saw before the mirror, before the boundaries. And the first and very important personality we have, Leonardo da Vinci. The person which excel in the field of art and science. Think about it. Science and art are entirely different disciplines at the time of traditional. But he was the master of art, science, engineering, anatomy, and architecture also. So one person can excel in multidisciplinary systems. And second, very important personality of our India, which make us proud always, who have written the national anthem also, excel in 14 fields, 14 different disciplines. Some are literature, music, education, philosophy, and art. Next are missile man, Dr. APJ Kalam. Excel in aerospace, engineering, science, policy, writing, leadership, and our beloved President of India. Next is Steve Jobs. Excel in technology, design, business, marketing. What a Apple person can do. Next is Benjamin Franklin. Excel, science, politics, writing, diplomacy, wrote US Constitution. He is the person who wrote some very famous guidelines or chapter in the US Constitution. Elon Musk. Have you heard about Tesla? Have taken education in engineering, business, physics, artificial intelligence, and space also. SpaceX is the contribution of that particular person. Kiran Mazumdar, so fields, biotechnology, innovations, and healthcare, and so on. So these are the persons. These are the personality who never ever think about the one discipline. Okay, yes, I am the engineer. They do excel in word. Here are some institutions we are already have already changed their objectives according to 21st century vision of India. These institutions can break traditional academic silos and prepare students to think across boundaries. One very prominent, MIT, USA, combines engineering, computer science, design, business, and humanities. Programs like Media Lab, MIT X emphasize cross-disciplinary innovations. Next is Stanford University, USA. A strong emphasis on collaboration between technology, medicine, business, and humanities. Home of interdisciplinary hubs like Design School. Harvard University, USA. Again, often joins program like law and public health, business and government policies, encouraging cross-registration across its various schools, like Kennedy School. And our Indians are not very old-fashioned, and the reimagination had already started in the Ashoka University. In IITs, like IIT Bombay and IIT Delhi, have started so many programs which are interdisciplinary in nature, which are multidisciplinary in nature. Aziz Premisi University, Tata Institute of Social Science, and some universities are in the race to grab the reimagining objective. OP Jindal Global University and Minerva University, USA. Okay, so these are some examples we have already started. We are already thinking about it. And what are the benefits? Improve creativity and innovation. In our traditional system, if we are not reimagining the education system, what we are doing, we are making very dull citizens. We are making very dull students. There is no criteria for innovation and think before you're out of the boundary. So this multidisciplinary approach learning will improve the creativity and innovation. Okay. What we are doing, if only the teacher is speaking in classroom, what the students are doing, they are dumb. They are thinking so many things because there are so many barriers. No? So better communication and teamwork also help them. Broader career options. If I am the doctor and I know only the surgical appliances, and I know how to make an operation of some specific body part, and I am very rude, and I don't know how to deal with public, so I'm not a very good doctor. So, okay, that's why it is very important to collaborate. Science with humanity, science with human values, solution with real societal impact. If we are taking so many degrees, we are achieving very good marks in our university examination or our school, and I'm not able to solve any very small problem, like I'm not able to make the reasons why this corrosion is taking place. So this is not a good sign, and that the process was very bad. So that's why it is a need of multidisciplinary learning, and we are doing the same thing. So it is not an optional, it is essential. Multidisciplinary approach is not a luxury, it is imperative. We face a future marked by uncertainty and rapid change. It connects ideas across disciplines. With define both personal and societal progress. Education system must evolve to reflect need by embracing flexibility, creativity, and cross-disciplinary synergy. What our country is doing? National Education Policy 2020, a turning point to attain the multidisciplinary point. The NEP 2020 promotes multidisciplinary education as a key element in reimagining education. It emphasized that students should be exposed to multiple disciplines and encouraged to think and learn across traditional subject boundaries. This approach aims to foster holistic development, critical thinking, creativity, preparing students for challenging of the 21st century. So it is very much important to shift our paradigm. What we were, what are the objectives in 21st century and how we will grab them. So if a traditional system was subject-centered, so there is a need to convert this subject-centered approach into the student-centered. We should not focus on only one subject. We should convert them according to the need of our student. And what we are doing, we are channelized our learning in passive way. But it is the two-way process. The faculty or student are equally important in the, it should be in the 21st century. So passive transfer should be shifted towards the active transfer. Competitive individual learning. In our traditional system, what we are doing, we are making the individual a very competitive part. But what we need, collaborative learning. The learning should be collaborative. What we are doing in our traditional system, we are giving only informations. But in current scenario, what is the objective? Or value-based knowledge is required. The knowledge we have, we are an individual, okay? We have so many domains. The knowledge should be based on 3 domains. First, cognitive domain, what knowledge we are giving. That means our theoretical point. Second domain is our psychomotor domains. If I am learning how the hardness can be removed from water in our book, so it is my responsibility to create an environment to students. They can feel how hardness is the part of water, how it is troubling to our boilers. A hard water can harm us. So we have to create the situation. We have to give their theoretical knowledge into the practical one. So shifting towards what we are trying to understand, what our knowledge we have. So it should be channelized. It should be practically involved. So every knowledge should have 3 domains. First is cognitive domain, what we are doing, what we are giving. Next point, psychomotor domain. Psychomotor domains means the knowledge should be based on learning by doing. What we are learning, it should be converted into the practical one. Next, affective domain. What we are doing, what we are getting, it should be sensitize us. If I am doing something which is good for society, which is good for our nation, is already always acceptable. So our knowledge should be based on cognitive domain, based on affective domain, and based on psychomotor domain. Learning by doing is essential. And by this technique, we can solve all the problems which our real world is facing now. Traditional evaluation system should be changed. What traditional system we have? We are completing our syllabus, and during the completion of syllabus, we are taking only 2 examinations. If I am taking the example of 10th and 12th class, in every board, what we are doing? We are taking 1 test that is midterm examination, and second test, that is the final examination. In any case, in board examination, the student is falling ill, what we will do? The board will fail the student. So this is the loophole of our paradigm. So it is going to be changed right now. Yes, there are so many schools which are giving the change in our evaluation system. Initially, it was summative system. Summative system means after completion of syllabus, we are taking the examination and we are getting the point would be our final result. Our final mark sheet will be the document which we will use entire life. The evaluation system should be changed. It should be changed in a formative way. It should be flexible one. If a student is coming college, so the evaluation should be on the basis of unit wise, on the basis of monthly, we can take the evaluation. So it should be formative, not should be summative. And transfer of mental knowledge. No, we have to change this development of the whole person. The development of personality is required only. What we are doing earlier, we were only develop. Yeah, we were transfer the mental knowledge. The change is important because it drives continuous improvement, foster personal and organizational growth, and leads to new opportunities. So it is a natural part. I'm not giving to change the entire education system. What we are doing, it was absolutely wrong. No. What I am saying, we have to change our system according to the need of the society. What is the requirement of real world? What is the requirement of our industry? What type of technocrats we want to make? It should be changed in this way only. Because earlier we have so many great personalities. Our faculty members gives, our evaluation system have given. So it was not entirely wrong, but it is a need of our. So change is the natural phenomenon. We should accept it. Next point. What should reimagine education look like? Integrated curriculum. It is very much important. Actually, curriculum is very important. If I am an engineer, that means I am not only in an isolated form of some specific branch of engineering. The curriculum should be integrated. In our curriculum, if we are able to connect physics and philosophy, literature and leadership, then it would be better for us. Project-based learning is very important. Okay, what we are doing is very important, but integration is also important. Project-based learning means that we are going to change the current curriculum. Curriculum is only the subject centered, but it not be subject centered. It can be changed. Like literature with leadership is very important. Project-based learning, if I am taking a example of climate change, so climate change is not problem of me. What problem we are facing in every year, in annually after the Diwali, the climate change, so many breathing problems occurring. The hospitals are very in a field condition due to some air pollutants present in the climate. Have you heard about ozone layer depletion? This ozone layer depletion is not a very small problem. It is very, very dreadful situation if it will occur. Okay, but this ozone layer depletion have observed in the Antarctica region where there is no population lived there. So all the problems we are facing is not the problem of our city, or it is the problem of not a state or not a country. It is the problem of entire earth. So climatic conditions have to be eliminated by project-based learning. If I am taking an example of water, so if I want to explain the concept of water to a student, that means first in science subject, we can integrate them. Water by water cycle. So we can explain the importance or significance of water in via science teacher. Second, integration in our literature. By literature, we can give the importance of water by literary person, by poems or stories. And water we can give the by policy or our ethics, because we are Indians, we can directly correlate the importance of water by the river Ganga, and we can give the importance of water. Skill and soul, it is very important. What we are doing, what we are making, it is very important. Collaboration is very important. What is collaborative teaching? Collaborative teaching means teacher from different subjects plan and teach lessons together. Like nanotechnology, a very important branch of science. In a chemistry, we can we can give the light towards what is the application of nanotechnology, what is the synthesis of nanomaterials. And in physics, we can give the tools, we can give the research areas of nanotechnology. And electrical engineers, yes, they can give a broad line towards the nanotechnology and all. Okay. Inquiry-based learning, yes, it is very important. A student asks question in classroom. The classroom should not be dull. A more very senior person is delivering the content and all. But it should be a freedom to students. They can ask questions, research answers, and present findings that cross subject boundaries. For example, I am taking the question, how does music influence mood? So this question's answers can be given by psychology, given by the physicist, how the sound waves works, and can be given by the arts, because there is a positive correlation between art and music. Experiential learning is very, very important. Experiential learning means field trips are very important. In my childhood education, I know how the Taj Mahal, which is in Agra, is a very is in the class of 7 wonders of world. And I also saw in my black and white textbook. That was not a great experience. I learned the same thing. What my teacher is saying, I'm just learning. And I'm learning in the way that I will write this type of question, or I will write this type of answer if the sir asked in my question paper. But when we saw the Taj Mahal, so this type of real life experience is very much important. What we are taking, internship is very important. In internship, you will meet so many people which are from different backgrounds. Okay, the internship is very important. In the internship, what you will do? You will learning by doing. You know what is the requirement of real world. You know how this machine is working. You know how how we will use the renewable energy resources in place of non-renewable resources. So it is very important to take the real life experience. It is very important. What is the role of teacher in this multidisciplinary approach? In a multidisciplinary education system, the role of teacher evolves from being a subject-specific instructor to a facilitator, guide, and co-learner. And all of we know that learning is lifelong process. Okay. So if I am a teacher, so I am not stagnant at the point that I have received all the degrees and now I am full-fledged teacher. No. I have to walk with the necessity of the global objectives. Okay. So rather than teaching isolated fact, okay, I have an attitude, I am the chemistry teacher, I cannot, I'm not able to give the answer which is from the literature, which are from the arts, which are from the sociology and psychology. No, it is not required. So this type of mentality we will change, or we are changing also. So rather than teaching isolated fact, the teachers help students make connection across various disciplines to solve real life problems and develop holistic understanding. So it is very important. Our role is also going to be changed. So we have to facilitate the student. Yes, so many books are written in the library, na? So many books we have library. We have a library which have 25 lakhs of book. We have 25,000 books. So every student can make a reading from there only. So what is the role of a teacher? It have to change. You will facilitate. You will try to read the mind of a student. It should be individualized. So you cannot take the instructions to the class. Your instruction should be based on the requirement of a student. What mental level the student have. What type of teaching method is required. The teaching methods, the teaching tactics have to change. It is very important. Okay, passive lecture learning can be replaced by the demonstration method, can be replaced by the project based method. So this project based method is very, very important. So a student can, by the project based method of learning, the student work on real world projects that require knowledge from multiple disciplines. I'm taking an example. The project on sustainable cities can evolve geography. Why geography is important for sustainable cities? Because urban planning is important. Science resources are required. We want to have a mathematician in our project for data analysis. And the civics, we know how many government policies we have in completion of the data. Next point, what we will change in our multidisciplinary approach evaluation system. The evaluation goes beyond traditional examinations. This type of traditional examination make the students very, very tense. And according to the recent data which I have read today, 64% students face stress during their examination. And out of these 64% students, 16% students have the feeling of suicide. So that is the main fact, because nobody is more important than a student. If we are trying to educate the student, so it is not essential that we have giving them stress, because stress is not directly proportional to the achievement. So it have to be changed. Evaluation system, that's important. Project based. We have to divide the entire classroom in very small groups. And these small groups can do wonderful. Actually, not an even or single student can learn or can think about the one problem in so many ways. So it is the need and it is very important. And in collaboration learning, the most favorite example of mine is Chandrayaan-3 mission. It was the best example of collaborative efforts of engineers, scientists, researchers, and technologists. Their collective knowledge and expertise were critical for success of learner. The team's motto was, failure doesn't mean defeat. They don't want to defeat themselves. The team's hard work and never give up attitude is starting way break to 2008 with Chandrayaan-1 and leading up to the success of Chandrayaan-3 in 2023 show their incredible perseverance. So this is very important. Collaboration learning is important. Integrated curriculum is our need. Project-based learning is our need. Skill is very important, but we have to sensitize our students. And it is very important. If I am living in the 21st century, so I have to know what is the emotional intelligence and how it is important. What is the sustainability? Actually, to fight any climatic problem or any interborder problem, it is not only the work or the responsibility of our government also, na? So it is the responsibility of every citizen. If I am talking about the cleanliness, so it is not responsibility of our government, and it is not the celebration of only 2 or 3 days. What we are doing, we are planting a tree. Because in our environment, oxygen is going to be polluted and we are facing so many problems. That's why planting is important. But no, it should be sensitized. If we are giving the student to the lesson, please plant the trees. So we have to educate them. Please bringing up them. Okay, don't say ki please we are putting a plant and we are clicking so many photographs, just showing, just we are not honestly contributing to our society. Digital fluency is very, very important. Okay, the individual education I think is not very good, but it should be very much personalized. So it is very important that we have to reimagine our education system, because it brings together professionals from different disciplines. Psychologists, education therapists are very important. If I am talking about the school system or in our college life, our subject expert is important. Our different teachers are also important. A psychiatrist is also important. Therapist is also important. And in a whole, they can change the personality of a student. So the old basics we have fragment. It is going to be changed with connect. Tolerate, we have to change with care. Obey, we have to change to be critical. Actually, critical analysis or critics is very important. What we have old basics compete. So it should be collaborate. Reproduce is not very important thing. What was the scenario of a research system? What we are reshaping the ideas, reshaping of the concept we have already have. So in the 21st century, it is the need to create something new. If I'm talking about the electrical vehicles. So if I'm not talking about the electrical vehicles, that means we are not doing according to the necessity, according to the our situations. The goal, empowered and adaptable humans are very important. The future does not belong to those who know only one thing. Very well, it belongs to those who can learn, who can unlearn and connect the dots between disciplines, to create, to lead and to heal. Reimagining education is not just an option, it is an imperative. Let us move from rote learning to real learning. Because if we are rote, we are using the rote memorization. That means in coming days, it will be removed from our mind. If we are doing something in the field, we are doing something in laboratory, we are doing something in our experiential learning, it will be lifelong. So let us move from rote learning to real learning, from narrow specialization to broad understanding, from marks to meaning. Okay, the marks are not important. Yes, I'm not discard the concept, but meaning should be knowing by us. Let us prepare not just better professional, but better human being. Because professionals, the motto is entirely different, but human being can never ever do which is against our society. So reimagining education is not option, it is imperative. To thrive in 21st century, we must move from memorization to meaning, from passive reception to active creation, and from isolated subjects to interconnected knowledge. So this was all from my side.
Thank you so much, ma'am, for your wonderful presentation. I request any of the guest side or participant side, if you have any questions or wish to interact with ma'am, it is welcome.
I think it was a wonderful presentation where the interdisciplinary knowledge is required and essential in today's era. And what was presented here was also it was presented in different perspectives by previous presenters, just emphasizing this particular need, which is very interesting. We had similar concepts where the teaching or imparting of knowledge should be individual, student-based. It shouldn't be just for top students or bottom students, average students. It should be for everybody. I liked that. In the beginning of the conference also, there was one lecture by Avanti Yamamoto that talked about very same thing, individualized, student-based teaching. And there was one lecture by Dr. Dhanushkodi Rangaswamy from Sarawak, Malaysia, on collecting the metrics of learning of the students' abilities, and then mapping them, feeding them back into giving questions and developing curriculum and so forth. Even in my presentation also in cybersecurity, interdisciplinary was emphasized because cybersecurity, even though it sounds too technical, really it is interdisciplinary. One should know, one should have knowledge in writing, speaking, being able to express and explain, articulate a risk or a security problem if it exists, and articulate the solution effectively to the management. Cybersecurity also needs background in law and so forth, somewhat. And then ethics. I think this was a wonderful presentation, which clearly talked about today's needs, especially in the rural areas where some students, they don't have the financial ability. How do you handle it? And fortunately, we have the distance education and Zoom, WebEx kind of facilities available today, which would help. It was a great presentation. Thank you so much.
I want to say something.
Yes.
Yes, please. ma'am.
Okay. Personally, when I need what is the requirement of this reimagination of education system or multidisciplinary approach, once the student of my section was asked me, ma'am, the electron of physics is the same, the electron of chemistry. So that type of gap we have in our education system. So thank you so much. And I am sincerely thank you, sir, Prakash sir, and SIDBI conference. Ma'am also, that was a wonderful topic. I have gone through so many case studies and the topic is very appropriate. And we all will learn a lot from this. And I am very thankful. And special thanks to a very talented and dynamic person, Dr. KK Shukla sir, for inviting me and wishing you continued success in all your future academic endeavors. I'm so thankful of you. Thank you so much.
Ma'am, should I speak if you will allow?
Sure, sir, you can. And always.
Actually, since ma'am, just one thing I want to tell you, ma'am. As I promised to the SIDBI Foundation, slowly, but I will give the good input. So ma'am, you can just see, that's why I told once ma'am will complete her speech, then I will tell. Actually, first of all, ma'am, Dr. Mamta ma'am, thank you so much for saying yes, because I know since I am working with you, so for meeting, if we are going for meeting to ma'am during lunchtime, near about daily, at least 20 students are there nearby her cabin. So that is the input she is giving in the college. Apart from that, ma'am is working as the NSS officer. Sports, overall, the entire college, sports and all those things taken care by ma'am. She is the HOD. Told these all introductions should not be given. That's why she has not given even that profile also to me to read out. So ma'am, thank you so much, ma'am. And actually, I have learned a lot of things. And today I'm really very much privileged because I don't had a chance to sit in her class. But whenever I am crossing nearby her classes, the energy level I am seeing even in the last period. Apart from that, the way she is teaching, it's really everybody have to learn. Being a teacher, I have learned a lot of things from ma'am. And in research side also, we are collaboratively we are doing. So especially I am requesting to all the dignitaries, Professor Dr. Prakash Rao sir, Professor Dr. Srinivas sir, and Professor Dr. Aruna ma'am. Very senior, our guest is here, Dr. Madhu Sharma ma'am. So I am just requesting for this foundation, actually such talented people are always required, and we have to appreciate their talent because, ma'am, actually we are in India, so we don't know from which corner what input we can get and what output we can produce. So really it is totally depending on the nature of God. And ma'am has during her presentation, she has given such a nice point. Actually, she has covered the technical education. She has covered how and what will be the social impact. And one very beautiful line she has told about the human being. Means everyone is professional, but more than professionalism, we have to just think about humanity. That really touched especially and personally to my heart. So thank you so much, ma'am. How much I will speak, how much I will say, it will be always minimum. The work and the dedication and the energy level you are giving, not only to the college campus, to all the students, to your colleagues, and upcoming all the generations. So ma'am, we are totally, how to say, blessed with you and speaking about you and seeing your work. No need to prepare any kind of a script or no need to prepare anything, a speech for you, because from past 2 years, I have got a chance to work with you and to learn a lot of things from you, ma'am. So really blessed with you. So ma'am, thank you so much. And I am really thankful to the Sidvi Foundation who had given the chance and all the dignitaries who has given the chance to me to put some kind of effort from my side. So sir and ma'am, this is the small effort, but with a very big person from my side. So I hope all the participants and everybody, those who are here in this meeting, definitely this speech will be the life changer speech for them. They will learn a lot and then they will be getting associated with this Sidvi Foundation by learning and enhancing their skills and all. So just my always pray to the ma'am, she should be always healthy, wealthy, and always the same energy and the same smile and the same whatever she is doing miracles and all, even in the playground and even on the stage and even in the field also while NSS activities are going on. Ma'am, one more thing I forgotten to tell. This year marathon was there, no ma'am, Delhi. So she is the person, because of her Dronacharya College students, they got the winners. So really, it's a very proud moment. And actually, she have a lot of achievements. It is not like one or two. So since time is limited and we are running out the time also, and even ma'am, she is coming daily from 2 hours from college. Her home is near about 2 hours. And after taking classes, doing all the work, she has taken such a wonderful presentation. So really grateful, ma'am. I can understand and I can see your hard work, your dedication, yeah, and the way you are representing yourself. Actually, greatness is there if somebody is really great and the particular person is not making others to feel you are lesser than her or lesser than him. So that is the beauty of great person, and you are one of that. So thank you, ma'am. Thank you so much. Really thank you.
So much, Kaustubh sir. You really are very ideal and very good human being. तो आप अच्छे हो इसलिए आपको सब अच्छा लगता है. Thank you so
Thank
much. God bless you.
Thank you, ma'am.
Hello, this is Soumya. Ma'am, I have a question for you. You have mentioned about traditional method and modern method of teaching.
Yes.
So, my question is, to which extent these modern methods like online mode or hybrid mode of teaching will be impactful over the traditional method?
Okay.
Because as a teacher, I feel that more than this online or hybrid mode, I feel the traditional method should be along with the modern.
Yes. Okay. Thank you, Soumya. What I feel, traditional method is the best. Okay. If I am interacting my student in front of them, that means I can learn and I know what my student is perceiving because I am standing in front of them. But in case I am facing some financial problem, okay, I am not able to fill the some very hefty amount to the school. Okay, and in the case of some illness, and in the case of our COVID-19 duration, so this is the bless for us. So we cannot eradicate the offline mode of learning, but it is a better way. It can enhance our learning system, teaching learning process. So many times if I have to come to join the conference now, it would be very difficult for me, but we are interacting in the very कहते हैं ना कि very good and very continuation. So that's why it is an additional advantage for us. So many students who cannot continue their education, but they are completing the by digital way or online way, because very less amount of fee we are paying, but we are getting the education, we are doing the same. So we cannot eradicate the offline mode of learning. It is the best way. And how I am blessed. And in your childhood, you have so many teachers. We are your who were your role models. Now you always remember them because they are standing in front of you. But in digital method, we cannot cope up in the COVID condition. What we will do? The students who are not able to take online classes, now they are 2 years back from their colleagues, or you can say classmate.
I would like to add one thing
Yes,
to
sir.
the discussion. The biggest strength, as Prime Minister Honorable Modi said, the biggest strength of India is its population. We need to educate as many people as possible. Mostly they are in the rural areas, as we all know. I come from a small village in India, so I know how it is. How do you reach those masses? And on the other side, the donations so the private colleges donations, they are so astronomically expensive, as you can see that, because I have so many children for my own family in India, how they are struggling to pay the donations to the private colleges, because there are so few universities which have low fee, but most of them, they are private. You need lakhs and lakhs of rupees you have to pay. That really deprives so many smart people, highly deserving individuals. So how do you reach out to those masses and help them learn? That is online. They can sit in the rural areas, towns, villages, and then learn remotely. They don't need to live in Bangalore, Mumbai, Hyderabad, where the cost of living is high. There's no need for that. They can stay wherever they are and still learn. Granted, face-to-face Guru Mukha Vidya, as is said in the Sanatana Dharma, that's the best. But we have to adapt it to the modern times and the needs today. And also one more benefit of this online mode of education is you can easily show it. Statistics, you can show examples, you can show processes in place, and you can even interact with the students, the lecturer or the teacher. There are so many advancements are there and more to come. So there is this is how I strongly feel how we can make India number one country in the world. I know we can do it. Thank you.
Exactly, sir. I also agree with the explanation of Prakash Rao, sir. Here in India, I don't know when it will be implemented, or in some states it may be implemented. Modi sir introduced a curriculum, a new curriculum, in a national education policy. In that, 80-20, 80% of teaching in classroom and 20% they can learn from their homes through online. Actually, in AP, here it had not been implemented now, still, but I don't know in some other states it had been implemented or not. But exactly what you said, that is Gurumukha Vidya is very much needed in this era, sir, because not only getting the knowledge from Guru, coming to college or coming to school will impart some additional qualities to the student, like coming to the class by time, that imparts punctuality, and wearing the uniform, that imparts equality among the classmates, and listening from the teachers, which will impart some interest and some creativity. What not everything can have by the student by habituating to come to the class or come to the school or college. So this all the time I agree that it is very much needed. And as far as this is the digital era, and we need to learn some technical aspects also. So it is needed to have some online classes also. So there is a need of all these things. And one more thing I wish to add to Mamta ma'am, that ma'am, thank you so much. Actually, till now, in my mind and in my heart, some pain is there. All the time in engineering colleges, there will not be much importance of for science teachers, because the basic sciences will be there in first year only, and afterwards the students will go to their own core branches from second year onwards. So second, third, final years, 3 years, they will be with the core faculty only, and the first year basic sciences teachers will go only for 1 year. So they will not give any importance to the teachers, as they see the sciences as very lean. So this is, as a chemistry teacher since a long time in engineering colleges, I have that pain. But as far as much as we can encourage the students in multidimensional and multidisciplinary areas, we also can create our own environment being a science teacher in the core subjects also. That has been proven by Mamata ma'am. Thank you so much, ma'am, for giving me this strength also. Thanks a lot for your wonderful speech. Over to Madhu Sharma ma'am, if anything from your side, ma'am.
I must appreciate Mamta ma'am for such a wonderful presentation. What I want to say, ma'am, that this is a need of an hour, because multidisciplinary in traditional methods needs a lot of infrastructure. So by this using platforms, we can give multidisciplinary education, so that all-round development of the students can be done. That's all from my side, ma'am. Thank you very much, ma'am.
Thank you, ma'am. Thank you so much. And some engineering faculty here, like Kaustup sir, being electronics and communication engineering, sir, please encourage your students, whatever the science theorems they had learned, the technical knowledge is started from science theorems itself. So the practicality of science itself is the technicality. You please all the time encourage the students in that manner. As some IITs and NITs, they are having one subject known as life sciences for engineers in their second year course, sir, I think. So that is a very important course. Every engineering student must learn that life sciences for engineers. For example, we can relate the human eye with the camera. So how the human eye lens will work, the camera lens also will work the same thing. So like this, many things are there in the science which can be having the practicality and the modality of invention of the technical goods. So I request you, because I could see here you only as an engineering faculty. I don't know how many of there here from engineering colleges. So I request you, sir, to please encourage your students that science is also as much as important, just like technicality also.
Ma'am, here I will take one moment to answer one thing. Ma'am, truly speaking, with my experience, what first year faculty members are giving while I was studying, or now what even my students are studying, ma'am, it is not a criticism on anyone, but the real fact is students cannot forget any first year faculty, ma'am, because while they are entering in engineering college, that is the physics, chemistry and maths faculty, they are telling to the students how to behave, how to start your studies, how to start your studies, all those things. It is only given by first year faculty members only, ma'am. So whatever they are studying in physics, chemistry and maths, it is going whenever they are growing. So it is always encourageable, not only by me, and actually students itself, they are encouraging, ma'am, because they know the field. While students are coming in third year, then they are missing the first year faculty. While they are coming in final year, during their farewell, they are remembering, okay, this sir has taught maths, this ma'am has taught chemistry, this sir has taught physics. So it means that our student itself, they are praising the science and all the basic science and applied mathematics, all those things, ma'am. So it is always a matter of pride, and we all should understand the value of first year, because that is the base. Without first year, a student cannot go final year. So definitely, ma'am, I am encouraging, and even I will encourage more after this lecture, ma'am, for sure.
Thank you, sir. Thank you so much. Thank you. I request any one of the participants, if you wish to interact with ma'am, it is welcome. Okay. I request Kaustubh sir, could you please give a vote of thanks for these two sessions, sir?
So finally, it is my pleasure and it is honor to conclude the session. So I can see here all the dignitary of Sidvi Foundation and all the guest speakers, both the ma'ams. So really, I am thankful, and on behalf of Sidvi Foundation, we all the members of Sidvi Foundation, we are grateful for our both the speakers for enlightening the session and for this eye-opener session. Really, it is very close to the real life, and both the sessions has been taught by both our speakers to think about the solution, not only question about the problems. Don't always think about the problems. So that is the message what we have learned. So thank you so much, Dr. Renu Devi ma'am, Renuka ma'am, and our Dr. Professor Mamta ma'am. Thank you so much, ma'am. Thanks a lot.
Thank you, sir. Thank you for your wonderful vote of thanks for these two sessions. Almost we came to conclusion. Tomorrow only left. So I request all of you to please continue your support up to tomorrow itself. And let us meet tomorrow. Now I can officially say this meeting has been concluded. Thank you so much, sir.
Thank you, ma'am. Thank you, sir.
Thank you so much, everyone.
Thank
Thank you, ma'am. Thank you so much, ma'am. Let us meet again, ma'am. Thank you.
Okay, thank you.